Here's the victorious Mercury's lower unit after 3 hours of the oyster bar crossings. Notice how half the skeg has been worn away. The motor has not been harmed in any way. In the next test, a telephone pole is the obstruction the Mercury will face in the final test of durability, engineering, and design. The pole will be anchored out in the bay with concrete weights. Notice the motor being used on the pickup boat there. It's the 10-horsepower Mark 10. It has the first automatic transmission in an outboard, which allows one-hand control of speed, forward, trolling, and reverse operation. Engineered primarily as a fishing engine, its design has a new slant to slip through weeds and slide over obstructions, and the exhaust is sent out through the propeller hub in order to bury noise and gases far astern in the prop slipstream. The power head is actually tilted, too, inside the cowling to permit simple drainage of the puddles of unburned gasoline and condensation that form in any engine under extended trolling or low-speed conditions. This telephone pole is a more serious danger than most boaters will face, but every outboard owner knows what running over submerged or floating objects can do to a motor. At the Mercury Proving Grounds, this, too, is a routine double check on whether production is maintaining the required standards. Here comes the Mercury, over the log at 30 miles per hour. The motor flips up, and the boat hardly loses speed. Let's watch that in slow motion, photographed at 3,000 frames per second. This test is probably the most severe in terms of strain on the motor, its mounts, its clamp and swivel brackets, its underwater unit, that has ever been devised at the proving ground. Watch as the motor hits the log and is driven up. It breaks the water cleanly, coming out without much spray, due primarily to the design. The prop keeps turning with speeds up to as high as 10,000 revolutions per minute, while it is clear out of the water. As it comes back down, watch the rubber aircraft-type suspension mounts give and then adjust to help the motor settle into position. The clamp brackets of drop-forged aluminum, heat-treated to the strength of steel, have no trouble holding the engine even under this heavy shock. If a motor can take this, the owner doesn't have to worry about anything except damaging the boat. He can't hurt the motor. Since Motor J put itself out of commission on the oyster bar test, the other competitive model is rigged on the test boat to try to match the Mercury on this routine test. Certainly, owners of Model E would have confidence that this large-sized and heavy twin could turn in a creditable performance. Of course, these tests are not recommended for the average owner. He should be content to know that his motor is built to stand this treatment and such an emergency situation. Motor E is started, and the driver heads for open water. Here he comes, now over, but the motor is settling over to one side and beginning to fall off. Let's watch that same sequence in slow motion to see what happened. As the motor hits the log, note the tremendous amount of water thrown up as the lower unit heaves out of the water. Notice, too, how high the motor is thrown into the air, too far. The cowling door flies open, and then it begins to settle back. But the force of striking the log and the resulting strain on the clamp brackets, thumb screws, and suspension mounts has been too great. When the clamp brackets are weak, they will spring and come off under the impact. What happens here is that one of them does just that, and comes completely loose, letting the engine fall off to one side. The clamps had been tightened by the driver, but die-cast clamps, if turned too tightly, may break. Anticipating this, Mercury has for many years used drop-forged and heat-treated aluminum clamp brackets of aircraft quality to provide 100% greater holding power. Shifting of the motor when a clamp screw loosens, of course, is a very dangerous situation if there are passengers in the boat. Actually, all that kept this motor from falling completely off in the test was the steering cable, which held it long enough for the driver to get a handhold and hang on till help came. It was re-rigged and given a second chance to show its stuff. This time, the clamps were again very securely fastened. Here he comes again, heading for the log at about 30 miles per hour. Watch out. Here in slow motion is exactly what happened to cause this very serious damage to the motor and to create this extreme danger to any passengers he might have had. As the boat goes over the log and the lower unit hits, it is literally catapulted out of the water. Obviously, something breaks, and the tremendous impact sends it clear on into the boat. Notice how the propeller still keeps turning, creating an additional hazard. Think what would happen if you were sitting in that stern seat enjoying a nice afternoon in the sun. There is no question that with the progress in engineering, in the development of new metals, and in casting methods, owners should be able to have confidence in their modern outboard motors without fear of anything like this happening. In a close-up, the test driver shows exactly what occurred. One clamp bracket was broken. The other slipped off the transom, and the motor somersaulted into the boat. The die-cast clamp bracket with its coarse threads simply does not have the shock resistance and holding power of a drop-forged aluminum clamp bracket that enables the use of fine threads for greater clamping strength and more dependable holding power. Also, the clamps can be turned more tightly and with no additional effort. Obviously, a forging is much more durable than a die casting. In fact, in 8 years of testing at the proving grounds and in all kinds of use by owners, the Kiekhaefer Corporation has never had a report of a broken mercury clamp bracket. This is one of the many safety features that are offered to the public by Mercury as a result of this year-round testing. Looking at the lower unit of motor E, you can see how the blunt football-like gear case caught under the log and gave such a tremendous shock to the motor, its clamp brackets, and suspension system. Certainly objects much smaller than the telephone pole would place almost as much strain on the engine because of the protruding gear case. The Mercury's lower unit, as previously seen in the Hyacinth test, has no similar projections and is completely streamlined to glide easily over submerged or floating objects. In fact, the streamlined unicast Mercury lower units became famous years ago as the only motor that would stand up in the famous jumping boat shows seen at Florida's Cypress Gardens and on numerous television programs. The motors used made over 500 jumps without any damage to the unicast gear cases. Without a doubt, the sole aim of the Kiekhaefer Corporation with its advanced engineering and extensive testing program is the development and production of safe and dependable outboard motors with outstanding performance for the boating public. Outboard motor owners and prospective buyers can have confidence in Mercury.